In this video, we will learn about doubly linked list. So we have already discussed about singly linked list. This singly linked list. But in this video, we will discuss about doubly linked list. As the name suggests, what is a doubly linked list? What is a doubly linked list? So as we have discussed, what is a linked list? So linked list is basically a collection of objects called nodes. This is a linked list. And in the case of singly linked list, what I have told you that singly linked list is consist of node, and node is consist of a data plus a pointer to the next node. Means what will be the next node after that node. That is what a node of a singly linked list consists. But when we talk about doubly linked list, when we talk about doubly linked list, as let's say this is a node of a single linked list. So we have a data inside it. We have a data inside it. And we have a next pointer. Means what will be the next node where this particular node is pointing. In singly linked list, we have a extra pointer, which is the previous point. Which is the previous pointer. And that is called the doubly linked list. So if someone will ask you what is doubly linked list, so double linked list contains two pointers, double pointers are there, which is the next pointer and the previous pointer. That is why it is called doubly linked list. That is why it is called doubly linked list. Now, just like we have discussed about the operations in singly linked list, like how we can add a node, how we can delete a node, how we can insert a node, everything. In this case also, we will learn each and everything, how we can perform these operations on doubly linked list. So let's take example of a linked list. So let me write, this is let's say the first node, the data is 1, which is pointing towards the second node, let's say 3, then a third node, let's say 7, then a node which is let's say 10, and then null. Similarly, we will have a previous pointer also. Okay, so if let's say this is our head, and if I will ask you that which is the next of head, next of head will be basically this 3, which is the next of it. This is the next point. If I will say which is head previous, so its previous point is null. So you will say null. This is how a single linked list is. In single linked list also, what we will do is that we will have a header pointer from where that linked list is starting. Just like in this, just like in double linked list also, we have a head pointer which is starting from the starting node, from the first node of the given linked list. That is what is given to us. This is given to us in the particular case. Now let's say we have to, the first case is that we have to add a new node at the front. So just like we have discussed in the single linked list case, we will perform the similar type of operation in this doubly linked list. Let's see how we can insert a new node in this doubly linked list. Let's see this thing. Okay? So what we will do is we will have a new node here. So currently you can see that its previous pointer is null. I've erased it, sorry for that. It is null. And we have to add, let's say, a new node whose value is 5. So currently this node's next pointer is also null and its previous pointer is also null. Let's see how we can insert this new node at the start, at the front of this linked list. So this new node is, let's say, n. This new node is n. N is pointing towards this new node. So what we will do is, there will be a very basic operation that we will do. There is a two-step operation. Let me tell you. First of all, what you will do, you will make n dot next is equal to head. So the next pointer of this null will point towards head. So next pointer of this null will now point towards head. Now the second case. Where will be the previous pointer of this head work? So the previous pointer of this head will now point towards this end. So the previous pointer of this head will now point towards this end. And this is the only thing you have to do. The third case will be only that you will make head is equal to end. So now this head pointer will point towards this node only. And now you can see that this is our final linked list, which is starting from this 5, and we have added this node 5 at the start. This is how you can see we can add a node at the start of the linked list, at the front of the linked list by using these 3 steps. Now let's discuss how we can add a node, at the middle, or basically at a particular position in a linked list. How we can add that? Okay. So let's say that this is a linked list as it is. You have to add a node 5 in this place. So we have, let's say, created a node 5. Let me write it here. This is a node 5. Currently its next pointer is also null. Its previous pointer is also null. Okay. Now we have to add this 5 in between this 3 and 7. Let's see what we will do. So let's say that to make it between 3 and 7, first of all, what I will do, I will make my pointer at 3. So let's say we have a pointer, current pointer at 3, and we will always have our head pointer at the first node. So our current pointer is here at 3. That is what we know. Now we have to insert this 5 between this 3 and this 7. We have to insert this 5 between them. So for inserting this 5 between them, what we will do is that the very first step will be we will first make, this is a new node, let's say n. I will make n dot next is equal to current dot next. Because here in this doubly linked list case, we have to deal with the 2 pointers, not only the next, but we have to also deal with the previous pointer. So the same thing we are doing, basically the same thing what we are doing in that case, in the case of a single linked list. But the only extra step which we have to add is here we also have a previous point, and whenever we have a previous pointer, we have to perform this particular. Whenever we have a previous pointer, we have to perform this particular step. Okay. This is what we have. This is the particular thing that we have here, and that we have to basically perform. So the next basic thing will be that first thing is that we will make our n dot next is equal to current dot next. So currently our next pointer of n is pointing towards null. Now it will point towards current next, and current next is nothing but 7. So it will point here. The next step will be that I will be making that make. So this is the next step that we are going to. Okay. The step will be that n dot previous will be equal to current. So the previous node of this n will be equal to current. So now we have discussed about that what will be the next node of n and what will be the previous node of n. Now let's make that which node has its previous as at next and which node has its next at next. So what I will do, listen here. If I will write current dot next, so current dot next is nothing but this particular node. Dot previous means the previous pointer of this 7 is equal to next. That means what is this current next? This current next is nothing but this. This is current next. And I am building that current next previous pointer. Previous pointer of this current next would be at n. So this particular previous pointer of this 7 will now put this n. This is our n now. This is our new node. Similarly, what I will do, I will make current next is equal to n. So this current next will be subtracted from here and it will be at n. This is how we can insert a new node in between two nodes. This is the another case how we can perform insert operation in this doubly linked list. How we can perform insert operation in this particular given doubly linked list. This is the final case. Now, similarly, let's say if we have to insert a node at the end. Let me first write some values. So let's say this is the case. So this is how our doubly linked list looks like. And we have to add a new node at the last of the given link. Let's say the new node is here, which is let's say nothing but 2. Currently its next point is null, its previous point is null, and its name is n. We have to add it at the end. The first thing is we have to iterate till the end of the linked list. To iterate, just recall what I have told you at the time of the single linked list, that just take a while loop, take a current pointer that will be equal to head only in start. Current dot next is not equal to null. Till this will happen, you have to just make current is equal to current dot next. जब तक ऐसा हो चलते जाओ, and at the last your current will reach here. Now let's see what will be the steps we have to take. The steps will be very fine. First of all, we have to make next n dot previous is equal to current. Means n dot previous is equal to current. The previous of this n, which is currently null, will be equal to current. Then I will make current dot next is equal to n. Obviously, this current dot next will become equal to n. And in this way, you can see that this node is attached at the end of the linked list. This new node is now attached at the end of the given linked list. That is what we have discussed. So we have discussed the insert operation. Insert, how we can insert at the front of the doubly linked list, how we can insert at the middle, or you can say at a particular position of a doubly linked list, and we have discussed how we can insert at the end of this doubly linked list. Now next case will be how we can delete. How we can delete in a doubly linked list. The deletion in doubly linked list is quite another and is quite different from the single linked list, because as I told you, in doubly linked list we have also track of the previous pointer. We have to also discuss about the previous pointer. So now let's talk about deletion in a doubly linked list. The traversal in a linked list, doubly and singly are same. Everything is same, but there are some differences in the insertion. That is what we are going to discuss. Now, let's again take a particular linked list. Let's say 1, then we have 3, then we have 7, then we have 11. Okay, here we have null, here we have null. Okay, now let's say we have to delete. The first case is, let's say, delete the front or the first node, the front node. Okay, which is this head node. This is our head, and we have to delete this head node. We have to delete this head node. So what we will do now? Okay, so in single linked list, just remember, just recall that thing. What we have to do in this case in single linked list, if there will be a single linked list, we have to just do the one step, which is head is equal to head dot next. This is what we do when we have a single linked list. So let's say that we have done head is equal to head dot next. So head will be now here. Now head will reach here. But there is a problem in this code. In single linked list, we don't have any track of the previous node. हम लोग previous node में नहीं जा सकते थे. So we have assumed कि हम लोग जो पिछली node छोड़ के आए हैं वो lost हो चुकी है. हम लोग वहां कभी दोबारा नहीं जा सकते. That we do in single linked list. But in this case, you can see there is a previous pointer. If I will write head dot previous, it will again move toward that node, and we can't say if that node is deleted. So we do another thing, a new thing, which is head dot previous is equal to null. After making head is equal to head dot next, after making head to the next node, to the second node, we write head dot previous is equal to null. In that case, I will write this head dot previous to null. This is what we have. This is what we have. Okay. Similarly, now let's talk about how we can delete the middle node. If I will just again fix everything, and let's say if I am given with this current pointer here, and let's say if I've been told that I have to change, I have to delete this node 7. I have to delete this. Means the node after this current pointer. I have to delete this node which is present after this current pointer. How I can do that? That is what let's see we have to do to see what we will do. So if we talk about a single linked list, if we just ignore that we also have this doubly linked list, there is a very basic thing that I will recommend you. The basic thing will be that let's take a one more case. Okay, let's take a one more case which will be the let's say another pointer p, which will be current dot next dot next if it is present. This is the most easiest way I am telling you how you can delete the middle node. Okay. Now you can see p is at 11 point. Now you have to just do the one thing. You will make current dot next is equal to p and p dot previous is equal to null. You will see that this current dot next will point towards p and p dot previous will point towards not null, sorry, not null, sorry for that, not null, to current, to current. So it will be here at current. And using this particular thing, you can see we have basically deleted, because you can see now there is no way to reach this node 7. There is no way to reach this node 7. We can't reach this node 7. Neither from the current nor from the p. हम लोग कहीं से भी इस पर्टिकुलर नोड में जो 7 नोड है यहाँ पर नहीं पहुंच सकते, तो हमने वो चीज अचीव कर ली. How we can delete the middle node. Okay. Now let's talk about how we can delete the last node. So deleting the last node is quite, I think, quite easy. Okay. But then also let's discuss how we can delete the last node. So let's say this is a linked list, a doubly linked list. Okay. And here we have to delete the fourth node. The first thing will be to delete the last node, we have to delete the last second node. As I've told you in the last case also. In the singly linked list also I've told you this thing. And to delete the last second node, the thing I have told you is a while loop. You have to write while current dot next dot next. So we write current dot next to reach the last node and current dot next to reach the last second node is not equal to null. Till then we have to make current is equal to current dot next. So current will be here. Current will be here. Now the very simple thing I have to do is just make current dot next is equal to null. And when I will make this current dot next is equal to null, you can see अब हम लोग इस फोर्थ वाले नोड में कभी भी नहीं जा सकते हैं. There is no way to reach this last node. कैसे भाई, मान लो हम लोग 1 पे 1 से 2 पे आए, 2 से 3 पे आए, 1 dot next is equal to 2 dot next is equal to 3, 3 dot next is equal to null. 4 पे कैसे जाओगे? 4 भी आने कोई भी रास्ता नहीं है. That 4 node is deleted now. That is now deleted. And this is how you can see, this is how we have deleted, this is how we have deleted this particular node, this particular case. This is how we have achieved this particular case. Okay. So in doubly linked list, as I've told you, a doubly linked list is more about similar to a singly linked list only. It is very much similar to a singly linked list only. The only difference is that just like in single linked list we have the next pointer, in doubly linked list we also have the previous pointer. We also have the previous pointer. Okay, so we also have the previous pointer. So I have told you many things about that linked list. You can see here that we have discussed everything about inserts in a linked list. So we have discussed how we can add a node at the front. But just like here, you can see we were only dealing with the next pointers. We were not dealing with the previous pointers. But as you can see in this doubly linked list case, in the case of this doubly linked list, we have also we have also taken in consideration the concept of previous pointer, because concept of previous pointer is also important in the case of this doubly linked list. Okay. So if we talk about, just like you can see in this insertion of a single linked list, whenever we have to add a node at the front, what we were doing was that we were just making new node dot next is equal to head, and then head is equal to new node. This is the only thing we were doing. This is the only thing we were doing. But here, because we have a previous pointer also, we were also doing a new thing, which is head dot previous is equal to new node, so that the previous pointer of this head is now at the new node. This is the new thing which we have added. We have a previous pointer for each node also. We have a previous pointer for each node also. For each and every node, we will have a previous pointer. So this is basically making our iteration effective. So now also you can say indexing is not there. If you will talk about indexing, indexing is now also not present in this concept of this linked list. We cannot write this index there, which is the node at first index, which is the node at third index. We cannot do that. But there is a simplicity, because in linked list, as we are going forward, we can't move backward. But with the introduction of this previous node, इसके help से हम लोग previous पीछे की तरफ भी आ सकते हैं using this doubly linked list concept. हम लोग पीछे की तरफ भी iterate कर सकते हैं. That helps a more important, that means a very important case. Now, there is another concept that I wanted to explain you all. That is a concept of single linked list only, but because that I have not explained there, I just wanted to explain it here, which is a important concept, how we can reverse a linked list, or we can say reverse a singly linked list. So that is the case which I will discuss in this particular video. Okay, let's see how we can. Let's say we have a linked list like this: 1, 2, then 3, then 4, then 5, and then 9. And we want to reverse this link. Reverse means it will be 5, then 4, then 3, then 2, then 1, and then 9. I have to convert this linked list into this. And just remember one thing, not just the values. I just don't want it to change the values. I also want to change the pointers. Means the complete nodes should be reversed. The complete nodes should be reversed. This is what you have to do. Now let's discuss how we can reverse a linked list. So let me erase this thing. So for reversing linked list, what we will do? We will take 3 pointers. The first will be the current pointer. There will be a next pointer also, which will be initially null. So next pointer will be initially null hoga, and we will have a previous pointer that will also be initially null. There will be 4 steps that we write to reverse a linked list. The first step is just understand more clearly. Okay. The first step next is equal to current dot next. This next pointer will be equal to current dot next. You can see current is at 1, which will be starting at head. Next will be here. This is the first step. The second step will be make current dot next is equal to P. So in this is what I have done. I am making the next pointer of current equal to previous. So currently next pointer of current is pointing towards this 2. Now it will point towards this previous, which is null. Now the third step that we are doing is make previous is equal to current. So now this previous pointer will point towards this current. And then at the last, the fourth step, we have to make our current is equal to next. So this is basically we are iterating. In this way, our current is now at We have to do this thing until our current will reach at the null, at the last. Let's repeat this thing. Let's repeat. Okay, एक बार फिर से करते हैं. देखो, next is equal to current dot next. So next आ जाएगा यहाँ पर current dot next पे. Sorry. Next step. Current dot next is equal to previous. So current dot next जो previous की तरफ चला जाएगा. तो ये जो यहाँ से हट के क्या चला गया? Now previous is equal to current. Previous जो है यहाँ से हट के यहाँ पे आ जाएगा. And current is equal to previous. नेक्स्ट जो करंट आएगा यहाँ पर ऐसे कर. अब देखो, जस्ट ऑब्जर्व वन थिंग व्हाट वी आर डूइंग हियर. वी आर डूइंग नथिंग, वी आर जस्ट चेंजिंग, वी आर जस्ट इन्वर्टिंग द पॉइंटर्स. हमारा जो पॉइंटर ऐसे पॉइंट कर रहा है, ऐसे ऐसे पॉइंट कर रहा है. दैट इज व्हाट वी आर चेंजिंग. दैट इज द ओनली थिंग दैट वी आर चेंजिंग. वी आर चेंजिंग द डायरेक्शन ऑफ द पॉइंटर. We are changing the direction of the pointer of each node. We are changing the direction of the pointer of each node. Getting or not? Getting? We are changing the direction of the pointer of each node. So then what we are doing? So in that case, let's see, this will continue for all the other pointers. This pointer will also be changed, this will also be changed, this also be changed. And at the last are when our current will reach at the null pointer. At that point, our previous will be at the 5. It will be at the 5, means the last node. Then when our current will reach null, our previous will be at the last node. And now if you will just see this particular linked list from back, from here, you will see that this linked list is reversed. Now it is starting from 5, then 4, then 3, then 2, then 1. And that is what we want. We were just wanting this thing. We were wanting to how to reverse a single linked list. This is what I just wanted to explain, because this is a concept which will make you the concept of this linked list more clear. And these are the only 4 steps. Just learn them how we can reverse a linked list. So the main objective of this video was to discuss about the doubly linked list, and we have discussed about doubly linked list. Okay, just the difference was that in doubly linked list, it is also a collection of object called nodes. But nodes, there is a difference in the node, the definition of node. Node is consist of 2 pointers, not just the null, but previous pointer, which will make track of the previous node of that doubly linked list. It will make track of the previous node, next node, but with the next node, the previous node too. That is called doubly. The collection of object called node. Okay, and we have discussed about insertion, the deletion, and everything in this particular doubly linked list too. This is the complete explanation of how a doubly linked list work. As I told you, that it makes us very effective because it also has a previous pointer. It makes things very effective, so that if we are iterating in a single direction linked list, but we can't move back, but using this concept of doubly linked list where we have a, because as I told you that nodes are the classes which we define. We write, you can see here that when I've discussed with you the node, you can see that I've given you how I have here declared a particular class of node where there was a next pointer. If I will write one more thing here, which is this dot previous is equal to null, and thus that's the thing. We have another pointer called previous. This is the only thing. We have another pointer called previous, and now this is a node of a doubly linked list. Now this is a node of a doubly linked list. This is nothing different. The concept is very same. Just like here we were having a head, a next, and a node, we also have a previous pointer. That is the only thing that we will be having. That's the only thing, that's the only concept that we will be learning in this particular video we have learned. So linked list can be defined as a collection of objects called nodes that are randomly stored in the memory. Node contain 2 fields, the data and the pointer. The single node contain 1 pointer, the doubly node contain 2 pointers. The last node always point towards node. That is the only thing that we have discussed about node. I hope you have got this thing. Thank you.